Well, hello there. Today we're going to be working on some practice problems here from Activity 112, Simple Machines, and I'm going to be trying to work through these and help you work through them. So hopefully you guys have your sheet out and you could be working them at the exact same time to make it easier for you as we go forward with this and our upcoming lab. Okay, with this, the first thing they ask us to do is to do a complete annotation and to do some labeling. As I finish here, now I've got my annotation of here. I've said my resistance force, my effort force, the distance of the effort, how far away it is. Notice that I'm using the resistance with some type of box. Typically we show the type of effort with an arrow. Now the second question asks us for what is the actual mechanical advantage of the system. Actual is force, it's not distance, so I've got my actual equation over here for the formula. I substituted the numbers in. The resistance force was 50. The effort force was up here. That was 15. 50 divided by 15 is 3.3. Now, if you think about this in terms of pounds, and this is in pounds, those cancel out with each other. And our units here then would be nothing. There's no units on mechanical advantage. Now, in the second one here, I'm going through and using our work input equals work output. And FE times DE equals FR times DR, and that's the effort. The input is the effort, and the work output is the resistance. To go about solving this then, I'm going to have to substitute some numbers in. And I went ahead and substituted those numbers in. 15 was the effort force, 4 was the effort distance, 50 was the resistance force, and then X is the resistance distance. 15 times 4 is 60, divided by 50 gives us 1.2, and it was in feet. Okay, on here, I went ahead and made a picture of a wheelbarrow. Beautiful illustration, as you can see here. Notice I used our free concept, F-R-E, the fulcrum, the resistance, and the effort. I've got the 200 pounds, and then right here I've got the 200 pounds is 2 foot from the fulcrum, and then the effort is 5 feet from the fulcrum. On here they ask about ideal mechanical advantage. Ideal mechanical advantage deals with distance, and the effort distance was 5 over 2, which is 2.5. Okay, here's our equation that we're going to use to find this. For this then, if I start to substitute this in, the effort, I'll have to go back up here a little bit here again. Don't quite remember what that effort was. We don't know what this is. That's what we're trying to find. That's why I couldn't remember it. So I'm going to put an X in there. Our distance of the effort was 5. The resistance was 200. And that effort distance we said was 2. So it's going to be 400 divided by 5, or 80 pounds. Okay, on here I've done a real quick sketch of it. So what is the actual mechanical advantage of the system? Well, that's A and A. And as we know from class, that's force. So to go ahead and find the actual mechanical advantage of this problem, I'm going to take the 1/5, which is 0.2, and divide it by 1, and we get then a final answer of 1/5 is the actual mechanical advantage. This right here is the third class lever. It's not like the first one or the teeter-totter or the second class lever like the wheelbarrow. This here is the third class lever. Okay, on here now, to calculate this, force of resistance, distance of resistance. My resistance is 1/5 of a pound. The distance of that resistance is 4 inches. And then that's going to be equal to the effort force, which we said was 1 pound. And then the distance of the effort, which is what we're going to find. Well, 0.2 times 4 is 0.8. 0.8 divided by 1 is 0.8 inches. Okay, for this first one, the linear distance is just going to be the circumference of the of the wheel. So, what is the linear distance traveled in one revolution of a 36-inch diameter wheel? Well, the circumference is equal to pi times d. So that's going to be circumference, in this case, is going to be 3.14 times the diameter of 36 inches. Gotta turn my calculator back on. And we get an answer here of 113.04 inches. Okay, so what I've done here is, best I could, I labeled where the resistance force would be and the effort force, and then I labeled the diameter of the axle. So they want to know, what is the actual mechanical event? Well, that's going to be force. So AMA equals 200 over 30. Oh, shoot. That's supposed to be FR over FE. So I'm just going to draw a little arrow. That's what's supposed to be there. And 200 divided by 30 is indeed 6.67. Remember, there's no units on that. What is the required wheel diameter to overcome the resistance force? Well, hopefully by now you're starting to get this equation. And sometimes I'm going to admit I probably, without even thinking about it, flip it around. And maybe that's confusing, and I apologize. The resistance force, they told us, was 200. The resistance, it's going to be the diameter, and that's 1.5. And the effort force, they told us, was 30. So what is the diameter then of the wheel? Well, sorry, I got to get the calculator to work right. Actually, I got to punch things into the calculator correctly. Yeah, in this case, we found the diameter to be 10 inches. Well, from this point here, as I was saying, they want us to find actual mechanical advantage. Hopefully, actual is starting to ring a bell with force in your head. The resistance force is what's trying to be lifted. That's what's trying to be. They're lifting that. So that right there is my 560. The effort, it says, is right here. That's what they're having to lift with. That's going to be somewhere around 11. 11.2 is that. How many supporting strands? Okay, one of the things that we had not talked about previously is that here it's asking for supporting strands. And when it comes to a pulley system, what we find out is the number of support ropes is also equal to the mechanical advantage. So the ideal mechanical advantage, and that's what we're dealing with here, they're telling us it's going to take actually 11.2. So for us to be able to actually lift this, we're going to have to use the number of ropes, we could say, or strands, equals the AMA. Well, basically, it's going to take 12 ropes. 11 support strands wouldn't be enough because it's 11.2. So we're going to have an additional support rope here. So it'd take 12 ropes to be able to get this done. Well, hey, I hope this has been beneficial. Maybe you can keep working. That's the goal of this, for as long as you can. Try to see how many more you can get done. But it comes down to those two equations that we've been, or three equations we've been using this whole time, no matter what type of system it is. So hopefully it's beneficial. I'll see you on the flip side.